Hi dear students, welcome to Gita's classes. In this class, we are going to revise the entire topics of ordinary differential equations of higher order. That is Ode&Vc Unit 2. So, what is the order actually? If you have y is equal to f of x, then dy by dx is, that is once if you differentiate, we will get dy by dx. That is first order differential coefficient. Again, if you differentiate, you will be getting d squared y by dx squared, that is second order differential coefficient, and so on. So in the previous unit, we have seen only first order differential equation, that is only dy by dx. Now we are going to solve the differential equation which contains second, third order and all. So in general, the general equation is of this form. Equation number 1 is of the ordinary differential equation of higher order, that is nth order. Here you have d power n y by dx power n, that is n time you have differentiated. This is nth order differential coefficient. This is n minus 1th order differential coefficient, and so on. So this is the general form where a1, a2, etc. an are generally constants and f of x is a function of x. If you have a function, the coefficients as x, x squared and all, that is a separate method, we will see later. Next we are going to see the operator d. Actually, we can denote d by dx as capital D, and that is differential operator, and d squared by dx squared as d squared, and so on. If you denote, this is for our convenience, we are going to denote like this, okay? And please remember, if d is the differential operator, then 1 by d is the integral operator. So whenever you come across with 1 by d, you have to integrate, okay? So d power n, that will be useful for this integration. 1 by d will be useful for when we are finding the particular integral. So now when we are replacing d by dx by d, and here in this dy by dx, we will write it as d into y. If you have d squared y by dx squared, capital D squared y, and so on, okay? So if you replace like that, we will be getting the equation d power n plus a1 d power n minus 1 plus etc. a n minus 1 into d plus a n of y is equal to f of x. This is our given differential equation. Generally, we write it as phi of d. This is a function of d into y is equal to f of x, right? Now we are going to solve this equation. Solving this means what? Find y, the independent variable y, as a function of x, right? So if for this higher order, you will have two components. One is complementary function and another one is particular integral. That is yc plus yp. The notations are this. That is complementary function plus yp is particular integral. CF is complementary function and particular integral. PI means particular integral, okay? So you will have two functions, two parts in this solution. One is complementary function and particular integral. How will you find out the complementary function? If the and one more point you have to remember here, if the right hand side function f of x is equal to 0, there won't be any particular integral. Y is equal to CF itself is the solution, okay? You will not have particular integral. And so y is equal to CF itself is the solution. So even if you have right hand side function f of x, we will assume the right hand side function 0 and find CF, and depending on the right hand side function, we will find out particular integral. First we will learn the method to find out the CF, that is complementary function. So the method is, first you have to write the auxiliary equation just by replacing capital D by m. So m power n, here what do you have? This is phi of d. Phi of d is d power n plus a1 into d power n minus 1 plus etc. plus a n minus 1 into d plus a n, right? So replace capital D by m. So we will be getting nth order equation, nth order polynomial equation. That is m power n plus a1 into m power n minus 1 plus etc. a n minus 1 m plus a n is equal to 0. Solving this equation, we will get n roots. So depending on the roots, we are going to write the complementary function. So first case, there are different cases. So first case, if all the roots are real and distinct, distinct means different, okay, all the roots are real and distinct, then the CF will be yc is equal to c1. Please remember, if you have nth order differential equation, we will have in the general solution, we will have n constants in the solution. Okay. So c1 into e power m1x plus c2 into e power m2x plus etc. plus cn into e power mnx. This is the solution. Sometimes if one root is repeated twice, that is if two roots are equal, say m1 is equal to m2 is equal to m, and assuming the remaining are real and distinct, then the CF will be yc is equal to, see, please remember, whenever you have repeated roots, that should be reflected only in the constants. So two roots we are going to combine, remaining real and distinct. So c1x plus c2 into e power the repeated root. What is the repeated root? M into x plus the remaining are real and distinct. So c3 into e power m3x plus etc. plus cn into e power mnx. Okay. Sometimes, and instead of c1x, you can write c1 plus c2x also, no problem. Either c1x plus c2 or c1 plus c2x is also fine. And next is sometimes three roots are repeated. So assume that m1 is equal to m2 is equal to m3 if these three are same and remaining roots are real and distinct. Then what will be our complementary function is equal to yc is equal to, now we have three constants we have to incorporate. So whenever you have repeated roots, that should be reflected only in the constants. So three roots means c1 into x squared plus c2 into x plus c3 into repeated root is m. So e power mx plus c4 into e power m4x. If you have only three roots, we can stop here. Okay. This is generalized one, that's why I am writing e power m and x. How many ever constants you have, accordingly we have to write. Now, all are real we have seen. Now, there may be complex root also. So, if alpha plus I beta is a root, we know the property. If you have complex roots, they occur in pairs only. So, if alpha plus I beta is a root, definitely alpha minus I beta will also be a root. Then here we have two values, right? So two constants we have to accommodate here. So y is equal to CF is equal to, or YC is equal to e power, the real part, e power alpha x into C1 cos beta x plus C2 sin beta x. Assuming that the real remaining are real and distinct, we will say C3 into e power m3x plus so on plus Cn into e power mnx. Okay. Sometimes even the complex root may be repeated. So if alpha plus or minus I beta is repeated twice, that means alpha plus I beta we have, alpha minus I beta we have twice, right? So let us take m1 is equal to m2 is equal to alpha plus I beta. M3 is equal to M4 is equal to alpha minus I beta. Now how many constants we have to accommodate here? 4. So, and whenever you have repeated roots, that should be reflected only in the constants I told. So YC is equal to CF is equal to C1, sorry, e power. Now complex root means e power alpha x you have to write as it is. And C1, now we have to accommodate 4 constants. And for alpha plus I beta 2, for alpha minus I beta 2. So 4. So C1x plus C2 into cos beta x plus C3x plus C4 into sin beta x. Okay. So whenever you have repeated roots, we have to accommodate in the constants. Please remember that. So when y is equal to, when the right hand side function is 0, if the right hand side function f of x is equal to 0, then there is no particular integral. Otherwise, y is equal to cf plus pi. Assuming the right hand side is equal to 0, we will find out cf. And if, depending on the right hand side function, we have different methods for finding the particular integral. Let us find out the particular integral. Rules for finding the particular integral. And this is the equation. We have phi of d into y is equal to f of x. The same thing only I have written again. So generally always the particular integral will be, what particular integral means, first you can write 1 by phi of d into f of x. Okay. Then depending on the value of f of x, we have to follow the different methods. So type 1, if the right hand side function f of x is equal to e power ax, you have to remember replace d by a. So particular integral is what? 1 by phi of d into right hand side is e power ax. So replacing d by a, what will you get? Replacing d by a in phi of d. So 1 by phi of a into e power ax, provided phi of a not equal to 0. Whatever you are getting in the denominator, it should not be equal to 0, right? So 1 by phi of a is equal to 0. If at all, if phi of a is equal to 0, then what you have to do? Particular integral is equal to, here you have phi of d, no? You have to differentiate this with respect to d. That is 1 by phi dash of d. You have to differentiate with respect to d. And e power ax, and when you are differentiating, you have to multiply by x by 1 factorial. Okay, again repeat the same method. Replace d by a, that is x by 1 factorial into 1 by, again replacing d by a. So 1 by phi dash of a into e power ax, provided phi dash of a not equal to 0. If at all phi dash of a is equal to 0, if phi dash of a is equal to 0, then what will you do? Again differentiate. Okay, 1 by phi dash of d is there, no, here. Phi dash of d, again differentiate with respect to d. Okay, so pi is equal to, particular integral is equal to 1 by phi double dash of d into e power ax. Now what you have to do? X squared by 2 factorial. First we have multiplied by x by 1 factorial. Again you have to multiply by x by 2 factorial. That is x squared by 2 factorial into 1 by phi double dash of d into e power ax. Right? So now again replace d by a. Replace d by a. So pi is equal to x squared by 2 factorial into 1 by phi double dash of a into e power ax, provided again the same condition, phi double dash of a not equal to 0. If it is equal to 0, x cube by 3 factorial into 1 by phi triple dash of d into e power ax, and so on. Okay? And so on. So next is, so e power ax means replace d by a. Remember that. If it is sometimes sine of ax plus b or cos of ax plus b, or sometimes sine ax or cos ax also you can have, then replace d squared by minus a squared. This is what you have to remember. So pi is equal to 1 by phi of d into sine ax or cos ax. I am writing sine of ax plus b or cos. It is applicable for cos also. Okay. So here you have to replace d squared by minus a squared. So if you have phi of d squared, then you will be getting 1 by phi of minus a squared into sine of ax plus b, provided phi of minus a squared not equal to 0. Again, if it is equal to 0, the same method what we have done for e power ax, we have to follow that. Okay. And one more doubt I have now. Now we have d squared, I told you. So we may have d also, no? So sometimes you will be getting d plus 4 or d minus 4 and so on. So to make it d squared, you multiply and divide by d minus 4. For example, I am telling, if you have 1 by d plus 4 in the denominator, if you have d, then multiply and divide by its conjugate to make it d squared. If you want to know more problems, it is available in the channel under M2. M2 higher order differential equation. M2 unit 2, it will be available. All the problems I have done there. Okay. So next is right hand side function is x power k. F of x is equal to x power k. In this you have to remember two definitions, that is binomial expansions. 1 plus x the whole power minus 1 is 1 minus x plus x squared minus x cube plus etc. and 1 minus x the whole power minus 1 is. Please remember, here you have plus and minus, so minus plus etc. Here you have both are minus, 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 plus. Remember like that. So 1 plus x squared plus x cube plus etc. Okay. So now what is our particular integral is equal to 1 by phi of d. That is the general thing. Whatever function you have in the given function of d, you have to write as it is into x power k. Now you take the minimum term in this phi of d outside and make it in the form of 1 plus or minus another function psi of d into x power k. Then bring it to the numerator 1 plus or minus psi of d the whole power minus 1 into x power k. Into x power k. Now you have to expand, and according to this binomial expansion, we are going to expand this, and depending on x power k, we will stop according to this x power k, depending on that value. Next is type 4. Right hand side function is a combination of e power ax and v, that is 1 and 2 or 1 and 3. So v will be a function x power k or sin ax or cos ax. Okay. In this case, particular integral is equal to 1 by, always particular integral is 1 by phi of d into right hand side function. So e power ax v means, and one more point I want to insist here. Please remember, don't write it as for the first one. Type 1 I have written 1 by phi of d into e power ax, right? Always e power ax should be after this operator only. You are not supposed to write it as e power ax into 1 by phi of d. That is wrong. Okay. Wrong usage. So always after the operator only you have to write the e power ax. That means you are going to operate this operator on this function e power ax. Now e power ax into v. Now I am going to take this e power ax outside this operator, that is e power ax. If I taking it out, then replace d by d plus a into v, and depending on that function you expand this as a function of d, and depending on this capital V, it may be x power k or sin ax or cos ax, depending on that you have to write. Okay. Then next is type 5. If the right hand side function is x into v, where v is a function of x. Now again we have a separate formula for this. If it is type 5, then particular integral is equal to, always the first particular integral is always 1 by phi of d into x into v. In the previous one we have taken e power ax outside. No, now I am going to take x outside, that is x into, instead of 1 by phi of d, what I am going to write is x minus of, in the place of x I am going to write it as phi dash of d by phi of d into 1 by phi of d into capital V. Okay, depending on capital V, we will apply the formula. So phi dash of phi of d by phi of d, x minus of phi dash of d by phi of d, you have to remember, into 1 by phi of d of, instead of x, we are going to take it outside as x minus of phi dash of d by phi of d. Okay. Next is method of variation of parameters. Very, very important. One definite question you can expect for university exam also. Method of variation of parameters. So consider, and it is applicable for the second order equation. If the equation is of this form, then only we are going to use method of variation of parameters. If the right hand side function is not coming under any of the previous 4 types, then we have to 4 or 5 types we have seen. No, if it is not coming under any of these 5 types, then we have to go for method of variation of parameters. Or in the problem itself they will mention that use by solve this equation by method of variation of parameters. Then you have to use this. So we are going to solve the second order differential equation only. So first it is d squared y by dx squared. So what is the auxiliary equation? It will be m squared plus a1m plus a2 is equal to 0. So this is a second order differential equation, a second order polynomial equation. So m, if you solve, you will be getting 2 values for m. So therefore 2 constants. So y is equal to CFB, yc is equal to c1 into y1 plus c2 into y2. Okay. So whatever functions you have along with c1 and c2, we are going to take them as y1 and y2. Then the particular integral should be written as u into y1 plus v into y2, where u and we are going to find out this u and v. Okay, u is given by where u is given by minus integral of y2 into right hand side whatever function is there, y2 into f of x by w, and I'll tell you what is w, wait. So v is equal to integral y1 into f of x divided by capital W, where capital W is called the Wronskian. There is a name for this, it is called Wronskian. So Wronskian, how will you find out? Determinant of, here we have y1 and y2, no? So y1, y2 and y1 dash, y2 dash. Please remember, even for objective questions, you can expect Wronskian, and one more question also, define Wronskian also you can expect, okay? So determinant of y1, y2, y1 dash, y2 dash is our Wronskian, and you have to divide it by the Wronskian. U is equal to minus of y2 into f of x by w, v is equal to integral of y1 into f of x by w, where what is w? Wronskian of y1 and y2. So Wronskian, find the Wronskian also you can expect, questions like that you can expect, okay. Next is Cauchy's homogeneous linear equation. So here I told you in the beginning, the constants, if the coefficients instead of constants you may have some functions of x. Functions of x in the sense, if you have d power n y by dx power n, we can have x power n. And here for x for this x power n minus 1 and so on. If you have dy by dx, you can have x as a coefficient. Then this type of equation is called Cauchy's homogeneous linear equation. In this case, you have to make a substitution, and we are going to reduce this equation with a differential equation with constant coefficients. Okay. So where now you have to substitute, you have to remember this substitution. Put x is equal to e power z, or z is equal to log x. So please remember this, and wherever you have x d, you have to replace it by d dash. What is our d? It is d by dx, right? So d dash is d by dz, because we are going to introduce another new variable z. So d by dz is d dash. Okay, so x into d is d dash, and x squared into d squared will be d dash into d dash minus 1, and x cube into d cube will be d dash into d dash minus 1 into d dash minus 2. You can expect up to this only, not more than this. Okay, mostly up to third order differential equation only you will be getting for solving the problems. Okay, so x cube into d cube is d dash into d dash minus 1 into d dash minus 2, sorry, d dash minus 2, and so on. Okay, so now it will reduce. If you substitute like this, you will be getting a differential equation with constant coefficient, because xd will become d dash, that is d by dz only you will be having. And next is d x square d squared is d dash into d dash minus, you will not have x or y. Okay, so sorry, only x. Instead of x we will have z, but coefficients will become constants. Okay, so after that you can solve as usual in the using the previous methods with constant coefficients. We have seen different methods, no? You can solve like that. Next is Legendre's linear equation. In Cauchy's linear equation we had x power n, no? This is just an extension of this. Instead of x we can have a plus bx or ax plus b. So if it contains a plus bx the whole power n, a1 into a plus bx the whole power n minus 1, etc. This is called the Legendre's linear equation. In this case you have to make a substitution. A plus bx is equal to e power z, or z is equal to log of a plus bx. You can have a plus bx or ax plus b also, depending on that. Okay, so in this case again d dash is d by dz only. So here a plus bx into d will be equal to d dash. Sorry, here you will have one constant b also. So b into d dash. So a plus bx the whole squared into d squared will be equal to b squared into d dash minus 1. There we did not have b, so only x, therefore d dash into d dash minus 1. Here you have the coefficient of x as b, therefore b squared into. Then can you tell me a plus bx the whole power 3 into d cube will be b cube into d dash minus 1 into d dash minus 2, etc. So if you substitute in this equation, actually you have to substitute these things in this equation 1. Then it will reduce to one differential equation with constant coefficient. Here again this is equation number 1. You have to substitute these values in equation number 1. It will be reduced to one differential equation with constant coefficient. Then by usual method we can solve this. So please share this with your friends also, so that it will be useful for them. Please give a like and share it with your friends. Thank you so much for listening.